Okay, here we go on lesson 3, writing products as sums and sums as products. So, multiplication with addition and addition with multiplication. It says, for the beginning, to start us off here, solve the problem using a tape diagram. There's some vocabulary here. Diagram meaning a picture, a tape diagram kind of looks like a long piece of tape. A sum of money was shared between George and Benjamin at a ratio of 3 to 4. If the sum of money was $56, how much did George get? So let's do a tape diagram here. Here's George. It says 3 to 4. George and Benjamin. So George goes first, Benjamin goes second. Here's George. He gets 3. And here's Benjamin. He gets a ratio of 4. Based off of the facts of the problem, we know that the sum of the money is 56. So altogether, this is 56. How much did George get? So if 1, 2, 3, 4, 5, 6, 7, if 7 units equal 56, then that means each one of these units equals, what do you think? 56 divided by 7 is 8. Therefore, if George has 3 units, then George has how much? 24. George received $24. Okay, so imagine that one of these, since we didn't know the value, imagine that, call it X. What does the rectangle label X represent? So what does this mean? That means X equals 8. Just another way to look at it. So let's take our knowledge of tape diagrams, what we did up here, and let's represent 2 plus 3 using a tape diagram. So, or I should have said 3 plus 2, right? Here's 3. That's 3. Plus 2. So there's our 3. And there's our 2. So we could represent it like this. It could also be represented something like this, where this space represents 3 and this space represents 2. Obviously the 3 is bigger than the 2. Let's try this one, X plus 2 using the tape diagram. So X, remember, is our unknown amount. 2 we modeled up here. So if this is our tape diagram, we don't know this amount, so we would call that X. 2 has the same value to each other, so we would refer to that as 2. Now, using this picture here, what do you think is the approximate value of X in relation to these 2 units here? I would say approximately 6. It looks about 6 of those. Let's go with some more vocabulary. It says draw a rectangular array for 3 times 3 plus 2. So we know what 3 plus 2 looks like, right? Here's our 3. And here's our 2. So if we have 3 times 3 times 2, well then we'll have 3 of these. So there's our 3 from that, and then 3 plus 2. Can you do the same thing with the next one? Draw an array to represent. So let's draw a diagram to represent 3 times X plus 2. What do you think that one's going to look like? So we did X plus 2 a little while ago. There's our X, and there's our 2. If we have 3 of those, and we'll try again here. there's our 3. So there's the array, or there's the diagram of 3 times x plus 2. So another way that we can look at this if we just put it all together, we have 3 x's here, right? And we have 3 2's here. So how much do we have if we have 3 2's? We have 6. So another way we could have written that would have been 3x plus 6. That might look familiar to you from Coach Blackburn or Miss Jones last year. The distributive property, or the rainbow method, some of you have said. Hand out the multiplication of 3 to x and you get 3x. Hand out the multiplication of 2 to get 6. Notice it's the same thing. It's reminded to you right here. Distributive property, a times b plus c is the same thing as a times b plus a times c. Okay, let's practice using example 1 now. It says determine the area of each region using the distributive property. So if this is 11 and this is 16 and this is 5, then what do we do with these two? 16 times 11, which gives us 176. We would, if we have 11 5s, then together we have 55. That's using the array method, using your distributive property. Example 2, draw a tape diagram to represent each expression here. Each expression. So x plus y plus x plus y plus x plus y. Here is my x and my y. Notice they have 2 different variables, so they're in 2 different values. I have 3 of them. So my array method would look like this. One, 2, 3. Let's do the next one. X plus x plus x. Plus y plus y plus y. These have the same values here, so x plus x plus x plus, these have a different value, so we'll make them a little bigger, y plus y plus y. This is just given a visual representation to what these expressions mean. Now let's take C, 3x plus 3y. So if I have 3x, there's my x's, plus 3y. These are a little bigger because they're the different variable. It's the same thing, right? 3 x's plus 3 y's, 3 x's plus 3 y's. We could have made it look like this too. We could have said, whoops, 3 x's, x, 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 and 3 y's, y, y, y. There's 3 of them, so they mean the same thing. It's just a different look to it. Let's get a little bit. There you go. Sorry, I went off on that. So here's our x's, here's our y's, and there's a total of 3 of them. Let's do another one. Let's do 3 x plus y. If I have x plus y here, and then I have 3 of them, that's what that diagram could look like. So how many x's do I have? 3 x's. How many y's do I have? 3 y's. So there's the expanded form using the distributive property. do example 3 here. Find an equivalent expression by modeling with a rectangular array and applying the distributive property to the expression. So let's do the rectangular array first. Let's do, if we have 8x plus 3, there's our 8x's. I could break it up into 8 pieces if necessary. And there's our 3. It says times 5, so that means I have, there's 1, 2, 3, 4, 5. So there's my array. And what does this mean? If I have 5 8x's, then altogether I have 40x. If I have 5 3's, I have 15. We could have done, this might look familiar to you, 5 times 8x and 5 times 3, which gives us that 15. For parts A and B, draw an array for each expression and apply the distributive property to expand each expression. Substitute the given numerical values to demonstrate equivalency. So if we say that, here's my 2 times x plus 1. So if there's my x, since I don't know it, and here's my 1, I have 2 of them. So there's my 2x plus 1. So altogether, this means I have 2 x's and I have 2 1's. So I have 2x plus 2. It says to use this value to prove that they're equivalent. So if I had 2x plus 1 to start with, let's fill in a 5. According to this one, order of operations, multiplication happens first, and we get 12. According to this one, order of operations, your parentheses happen first. Again, we get 12. So we prove that they're equivalent. Let's do the same thing here to understand what 10 times 2c plus 5 means. Here is our 2c's. Here is our 5. So if we have 10 times 2c plus 5, that means we have 10 of these. Now we can draw them over and over again if we want to. We could say that there's 10. Or hopefully you can see that there are, and let me just do that for you. Notice it doesn't have to be perfect, but if we have 10 2c's, then we have, in this section, we have 20 c's. And if we have 10 5's, together we have 50. So this is equivalent to 20c plus 50. To prove that they're equivalent to each other, we could use your original and use the one that we just got from the array, and let's fill in 1. So 20 times 1 is 20. Plus 50 gives us 70. According to here, we would do our parentheses first. Multiplication, 2 times 1 is 2, plus 5 is 7, and then that 10 times 7 again gives us 70. For part C and D, apply the distributive property. Substitute the given numerical values to demonstrate equivalency. So here we have it doesn't say draw it. It just says apply the distributive property. My bad. So 3 times 4f, if you could visualize that in the array, you would have 12 f's. 3 times -1 would give us -3. So if you fill these in for both of them, let's fill in a 2 for f. 3 parentheses 4 times 2 minus 1 and 12 times 2 minus 3. If we solve it, 4 times 2 is 8, plus 1 is 7, and 3 times 7 is 21. 12 times 2 is 24. 24 minus 3, again, gives us 21. So they're equivalent. Hand out your distributive property. Let's practice again. 9 times negative 3r, we get negative 27r. 9 times negative 11, negative 99. So if we fill in 10 for r, let's see if they're equivalent to each other. Negative 3 times 10 is negative 30. Negative 30 minus 11 gives me negative 41. And negative 41 times that 9 gives me negative 369. If we did the same thing here, negative 27 times 10 is negative 270 minus 99, or plus negative 99, they mean the same thing, would give us negative 369. Example 4, rewrite the expression in standard form using the distributive property. Standard form meaning there's nothing to be combined. So right now we see both of these are constant, so we could combine something. So first of all, remember that whenever you are dividing by 3, that's the same thing as multiplying by the reciprocal. And then we could hand that multiplication out, because couldn't that look like this? So we could do 1/3. We just move the 1/3 in the front. So 1/3 times 6, a third of 6, x is 2x, and a third of 15 is 5. So this is in standard form because there's nothing left to be combined. Rewrite the expressions in standard form. Try some more. Rewrite it, not as division, but as multiplication by the reciprocal. You can put that multiplication in front to see it how you're used to. Then hand out that using the distributive property. Half of 2b is 1b, and half of 12 is 6. So I would really write that as b plus 6 because I don't write coefficients of 1. I'd like you to pause and try the next two by yourself. So here we have 20r minus 8 divided by 4. I'm going to write times 1/4, which is 1/4 times 20r minus 8. Then you can hand out that 1/4 of 20r is 5r, and 1/4 of negative 8 is negative 2. Let's do another one. 49g minus 7 divided by 7. That's 49g minus 7 times 1/7, or 1/7 times 49g minus 7. Then do your distributive property. 1/7 times 49g gives me 7g, and 1/7 of negative 7 is negative 1.